Imagine for a moment that you are looking at the starry sky, and suddenly the universe decides to defy all logic. You have in your hands data, equations, carefully calculated orbits, and then this distant object, which you thought you understood, begins to behave completely unexpectedly. It accelerates. Not because of the sun's attraction, not from a planetary impulse. It seems to move on its own. On Earth, we would attribute this phenomenon to an engine, to an internal mechanism. However, when this happens millions of kilometers away, in a comet gliding through the void, the astonishment is staggering. That feeling, that moment when physics intertwines with miracle, is what many scientists experienced observing the interstellar visitor known as 3I Atlas. A few weeks ago, while I was recording ideas at my computer, I read that the comet had accelerated for no apparent reason. I froze, pondering the implications. An invisible force? An error in our calculations? Or perhaps a hint of an even stranger phenomenon? In this account, I want to take you by the hand and guide you through the fascinating odyssey of 3I Atlas, pausing at its mysteries, our doubts, the boldest and most cautious interpretations, until we reach that enigmatic acceleration which stunned the scientific community. To understand this mystery, we need to return to its origins. On the first day of July 2025, the asteroid warning system, created to protect us from potential threats, detected a luminous point moving across the sky with an unusual speed. After analyzing the orbital data, astronomers concluded that this object was not bound to our sun. Its trajectory formed neither an ellipse nor a closed parabola, but an open hyperbola. It came from interstellar space, was to cross our cosmic neighborhood only once and then be lost in infinity. It was the third such guest recorded by humanity, after Oumuamua in 2017 and Borisov in 2019. Unlike its predecessors, 3I Atlas gave us time. Its detection occurred several months before its closest approach to the sun, allowing us to prepare for observations. We immediately calculated its speed. It was moving at over 130,000 kilometers per hour, setting records. We estimated that its nucleus had a diameter of several kilometers. And most importantly, we confirmed that it posed no threat to Earth. The closest point would be at more than 260 million kilometers away. Despite this reassurance, the excitement was palpable. We had before us a fragment from another stellar system, a messenger from distant worlds. However, the surprises were not long in coming and manifested as anomalies. One of the first images of the comet, taken by the Space Telescope, revealed something that contradicted the traditional description of such bodies. Instead of showing a tail of gas and dust, oriented away from the sun under the effect of the solar wind, 3I Atlas seemed to have a jet directed towards the star. This anti-tail, or inverted tail, puzzled many. At first we thought it might be an optical illusion, caused by perspective, but the spectra of the coma showed it was a real jet, composed of carbon dioxide and carbon monoxide, emanating from a specific region of the surface. The composition also proved unusual. The ratio of carbon dioxide to water was much higher than in comets from our solar system. Instead of being a ball of ice rich in water, this object seemed to be a reservoir of gases that were released at very low temperatures. Soon after, another discovery puzzled us. The Very Large Telescope in Chile detected vapors of nickel and a compound known as nickel tetracarbonyl in the clouds surrounding the comet. This compound, used on Earth in industrial processes, indicated unusual chemical reactions in space. Furthermore, iron was not detected in the same proportions. Everything indicated that 3I Atlas was not an ordinary comet. The list of its peculiarities kept growing. Another surprising aspect was its trajectory. Unlike most interstellar bodies, which arrive from random directions, 3I Atlas moved almost perfectly in the plane of the ecliptic, the same band in which the planets revolve. Tracing its route, we noticed it would approach Venus, then Mars and later Jupiter, before leaving our system. This sequence seemed designed by a cosmic engineer to use gravitational maneuvers or to study several worlds in a short time. From a statistical point of view, the probability of an interstellar comet following such a precise trajectory is very low, though not impossible. This alignment added to the anti-tail, the carbon dioxide-rich composition, the presence of nickel, the color some described as blue, and the exceptionally large mass for an object of this type. For some colleagues, these anomalies indicated the inadequacy of our models. For others, They fueled the hypothesis that 3I Atlas could be more than a comet. Some even called it the Trojan horse of the cosmos, a probe disguised as an icy rock. As a scientist inclined towards caution, I strove to remain on solid ground. I knew that peculiarities alone were insufficient to refute established theories. But human curiosity is inevitable, and unusual hypotheses began to circulate. While we discussed these ideas, the National Aeronautics and Space Administration took restrained measures. Although its representatives publicly insisted there was no danger, internally, protocols intended for potentially hazardous objects were activated. Observation shifts were increased, telescopes around the world were coordinated, studies with spacecraft were planned, and special attention was paid to any changes in trajectory. Some interpreted these actions as proof of a hidden secret, others as a reasonable opportunity to prepare for future scenarios. In parallel, the administrative shutdown of the United States government temporarily suspended the updating of some official websites. This coincided with a period when the comet was hidden behind the Sun, out of reach of Earth-based telescopes. The temporary coincidence fueled conspiracy theories, but when updates resumed, the National Aeronautics and Space Administration maintained its position. 3I Atlas is a natural comet with unusual behavior, posing no risk to Earth. However, the public's imagination was already stirred. Before moving on to the mysterious acceleration, another notable phenomenon occurred. The comet changed color and shone with unexpected intensity. At the end of September and beginning of October, approaching the point closest to the Sun, several observatories recorded that 3I Atlas took on a hue bluer than the Sun itself. Those who observe comets know that they usually appear reddish or yellowish due to dust and low temperatures dominating the reflection of light. In this case, the scattering leaned towards blue tones. Solar missions, such as Stereo A, the Solar and Heliospheric Observatory, and GOES-19, recorded a brightness that increased with a much steeper slope than that of any typical comet. In numerical terms, the brightness gain correlated inversely with the distance to the Sun to the power of -7.5. This rate of change was 7 or 8 times higher than that of comets from the Oort cloud. Furthermore, the blue color was not easily explained by heating. The comet's surface temperature was estimated at 20 times lower than the over 5,000 degrees Kelvin of the Sun. Any blue light had to come from other processes. The initial hypothesis was that carbon dioxide and carbon monoxide were ionizing, emitting light in the blue regions of the spectrum. Others proposed more exotic ideas: an internal engine, a plasma jet, or even artificial light. At that moment, the truth was unattainable. We only knew that 3I Atlas was not behaving like any known comet. Then came perihelion, the orbital point closest to the Sun. This occurred at the end of October, when the comet was about 125 million kilometers from our star, approximately 1.36 astronomical units. It was then that the news which concerns us appeared. The comet accelerated in a way that could not be attributed solely to solar gravity. The report by the navigation engineer from the Jet Propulsion Laboratory, Davide Farnochia, indicated that a non-gravitational accelerating force had been detected. The calculations showed that the object exhibited a change in velocity of about 135 kilometers per day squared in the radial direction, that is, moving away from or towards the Sun, and about 60 kilometers per day squared in the transverse direction. This acceleration was too great to be explained only by the typical outgassing of comets. This phenomenon added to the list of anomalies: the jet towards the Sun, the carbon dioxide-rich composition, the presence of nickel, the orbital alignment, the enormous mass, the blue color, and the rapid increase in brightness. When the news spread, the reaction was instantaneous. Some media spoke of an unexpected maneuver, a mysterious acceleration, and scientists in a state of shock. And indeed, many researchers were baffled. Trajectories were recalculated again and again. The equations of motion were adjusted to include an additional acceleration term. The question on everyone's lips was, what is propelling 3I Atlas? There are two main explanations for such phenomena. The first is known as the rocket effect or natural non-gravitational acceleration. This happens when a comet unevenly ejects jets of gas and dust. Each jet acts like an engine, pushing the nucleus in the opposite direction. If the comet is small and light, these jets can deflect it significantly. In the case of 3I Atlas, Previous calculations indicated that its mass was enormous, perhaps tens of billions of tons, making it unlikely that outgassing could cause a noticeable acceleration. Nevertheless, the natural theory could not be dismissed without evidence. Engineer Farnokia estimated that to achieve the observed acceleration, the comet would have to lose about 10% of its mass in a few weeks. This would mean ejecting a huge amount of material, creating a visible cloud for millions of kilometers. Such a large gas cloud could be detected by the European JUICE mission during its close flyby in November or by the Hubble and James Webb telescopes when the comet approaches Earth in December. If this cloud appears, and the acceleration simultaneously decreases, the rocket effect will be confirmed. Although extreme, this possibility was not impossible. After all, the comet was subjected to solar heat, releasing new materials that could release volatile substances with unknown forces. The second explanation, the one that captures the public's imagination, is that of an internal engine. Some wondered if the acceleration could be a sign of a propulsion system. An engine that activates precisely at perihelion to correct its course or speed. Those who supported this idea pointed out that the blue color and bright glow could indicate a plasma jet or a reactor emitting energy. An astrophysicist known for his openness called the acceleration the ninth sign of possible artificiality. On his blog, he compared the behavior of 3I Atlas to a vehicle performing deliberate maneuvers. He emphasized that if it is an engine, the acceleration would be clearly non-gravitational and would follow patterns of switching on and off. He also noted that if it is simply a rocket effect, the comet's mass should drop radically in a short time, which had not been observed so far. Proponents of the artificiality idea argued that the orbital alignment, the successive visitation of planets, and the richness in nickel fit the narrative of an artifact. Some journalists even used the phrase engine at full power to describe the event. And of course, social media were flooded with memes comparing the comet to a spaceship from science fiction. Meanwhile, the majority of scientists maintained a naturalistic position. They reminded that the term non-gravitational acceleration does not automatically imply intelligent engines. It merely indicates that other forces, such as radiation pressure or the thrust of gases, play a role. The classic example is Halley's Comet, whose orbit is adjusted taking into account non-gravitational acceleration terms. Specialists in comet dynamics indicated that a model of uneven mass loss could explain the acceleration of 3I Atlas without needing to resort to engines. They noted that the carbon dioxide-rich composition creates powerful jets at great distances, that the comet's nucleus may contain giant cavities that suddenly open, and that the estimated mass of the comet is still subject to uncertainty. Tom Statler, a planetary scientist at the National Aeronautics and Space Administration, insisted that, despite the oddities, 3I Atlas behaves like a comet in almost all aspects. His position was clear: nature is capable of surprising us with phenomena that challenge our models, and we must resist the temptation to immediately attribute them to extraterrestrial technologies. He also recalled that the acceleration data came from a single report and required confirmation by additional observations. Science advances with patience and evidence, not sensational headlines. To contextualize the acceleration, it is useful to understand how the forces acting on a comet work. When an object orbits the Sun, its motion is determined by gravity. This force always attracts the object towards the center of mass of the system. However, comets are fragile bodies, composed of ice and dust, which heat up as they approach the Sun. This heat causes the ices to sublimate, turning them directly into gas. If the surface has cracks or areas of varying composition, the gases escape with different intensities. Imagine a balloon with holes deflating. The air escaping from one hole pushes the balloon in the opposite direction. Similarly, a jet of gas accelerates the comet. In most cases, this acceleration is minimal and manifests on the orbit over many years. But for a comet with giant jets, the force can be greater. Additionally, solar radiation pressure also exerts a small push, though of lesser magnitude. Could the measured acceleration in 3I Atlas be caused by a combination of these two phenomena, amplified by its unusual chemistry? This is one of the questions that will be attempted to be answered in the coming months. Other factors can also influence. A recent study, based on data from the Swift Observatory, detected hydroxyl, a product of water decomposition, emanating from 3I Atlas. The presence of water indicates that, although other gases predominate, the comet contains water ice. Upon decomposition, water produces hydrogen and oxygen radicals, which can influence the dynamics. Furthermore, solar missions tracked the comet during its passage behind the Sun and observed outbursts of activity. The blue color could be caused by the ionization of carbon monoxide, which glows in this range upon interaction with the solar wind. It was also suggested that the comet's surface might be covered with dark heat-absorbing minerals, causing gas explosions in the hemisphere facing the Sun. All these variables complicate the equation. The only certain thing is that 3I Atlas challenged our expectations at every stage of its journey. The implications of this acceleration go beyond the specific case of this comet. If such an intense rocket effect is confirmed, we could be faced with an extreme example of how comets lose mass approaching a star. This would be important for models of how comets transport water and organic compounds to planets. It could also provide clues about the structural stability of large cometary nuclei. If the acceleration finds no clear natural explanation, we will have to consider unconventional forces, perhaps related to the interaction of radiation with exotic materials or non-linear processes in the sublimation of compounds. And in the unlikely event that artificial acceleration seems plausible, we would have to reconsider our position regarding the possibility of extraterrestrial technology in our vicinity. An engine would not necessarily mean a manned probe. It could be an autonomous device designed to correct its trajectory and collect information. Some suggested that an advanced civilization could send millions of interstellar probes across the galaxy, disguised as comets, to explore systems and transmit data. The Trojan horse idea is not new, but 3I Atlas brought it to the forefront of debates. Amid these speculations, other scientists offer alternative perspectives. Astrophysicist Suzanne Fegner suggested that objects like 3I Atlas could be seeds of planets in young systems. When a massive comet is captured by a protoplanetary disk, its mass and composition can accelerate the formation of a planet. In this sense, the observed acceleration in our system could be a remnant of its internal dynamics, not an external engineering achievement. Another theory assumes that interstellar comets could carry fragments of meteorites or even microfossils of life from their system of origin. If this comet is rapidly losing mass, it could scatter part of this load. Some colleagues suggested that its acceleration could slightly alter the dynamics of other smaller objects in our system, presenting a natural experiment in celestial mechanics. Although these ideas do not yet have evidence, they remind us that science feeds on bold questions. All this took place in a context where public communication is crucial. When the news of the acceleration went viral, many succumbed to exaggerated headlines. Some blogs and video channels proclaimed that the National Aeronautics and Space Administration was hiding an alien ship. Others hinted that the comet was about to escape our observation. As a scientist, I am concerned not only with truthfulness, but also with the impact of misinformation on public trust. It is true that the National Aeronautics and Space Administration can be cautious with information, but it is also true that any unusual discovery will be shared with the scientific community for verification. Claims about extraterrestrial engines, without data to corroborate them, can undermine trust in serious technosignature research. On the other hand, the scientific community cannot dismiss troubling anomalies simply because they seem improbable. There is a delicate balance between skepticism and openness. Over the years of my research, I have learned that data are paramount. We can theorize, imagine, even dream, but it is the instruments and measurements that determine the truth. The acceleration of 3I Atlas requires us to collect more data, compare models, repeat observations, and yes, question our assumptions. As a specialist in theoretical physics, I love turning numbers into a narrative that connects to human experience. When we say the comet accelerated by 135 kilometers per day squared, we mean its speed was increasing each day by that amount due to a force that was not gravity. For an object already moving at over 130,000 kilometers per hour, this represents a small percentage increase, but huge in absolute terms. Imagine you are riding in a high-speed train and suddenly feel an inexplicable push. That push, multiplied by the vastness of space, is what we see in the 3I Atlas data. The transverse component of 60 kilometers per day squared indicates that, in addition to the radial push, there was also a lateral deviation. This suggests that the force was not only pushing outward but also sideways. The exact circumstances of this deviation are still being analyzed. These numbers translate into accelerations of a fraction of a millimeter per second squared. They may seem small, but over astronomical distances they cause significant changes. Thinking about the acceleration, I also think about this visitor's route. After perihelion in October, the comet remained hidden behind the Sun for several weeks. It will reappear in our skies at dusk, at the end of November or beginning of December. The closest point to Earth will be on December 19, 2025, at a distance of approximately 170 million kilometers. Then we will have the best opportunity to study its characteristics with telescopes like Hubble and James Webb. The JUICE probe, heading to Jupiter, is scheduled to observe it in November. Later, in March of next year, the Juno orbiter will be able to collect additional data. During this period, astronomers will look for signs of a gas cloud that would confirm the rocket effect. They will also analyze whether the acceleration persists, ceases, or changes. If it is an engine, we might detect activation variations. If it is sublimation, the acceleration should decrease as the volatile substances are depleted. And if it is a completely new phenomenon, we will have to develop innovative theories. Among these expectations, I think about the symbolic value of the comet. 3I Atlas is a mirror, reflecting both our knowledge and our uncertainties. Every anomaly it manifests underscores our tendency to seek patterns. The inverted tail, the orbital alignment, the exotic composition, the unexplained acceleration, all are ingredients of a narrative that makes us reconsider our hypotheses about objects visiting us from other systems. At the same time, the public's reaction reveals our need for wonder and quick answers. When a phenomenon eludes our immediate explanation, we fill the void with fantasies. But science is not a speed race, it is a journey of endurance. It requires time, patience, and the willingness to correct our models. I know that some people are disappointed when we say that 3I Atlas is most likely a natural comet. I understand that. It is much more exciting to imagine that it is an unknown ship. But I must remind you that natural reality can be as captivating, or even more so, than any fiction. Non-gravitational acceleration, perhaps caused by the sublimation of gases, opens the door to a better understanding of the physics of these bodies. The blue color forces us to think about new emission mechanisms. The possible mass loss will allow us to determine if interstellar comets evolve differently from ours. And the very presence of 3I Atlas, a traveler 7 billion years old, connects us to the stories of other stellar systems. With every observation, with every spectrum, we decipher a fragment of the galaxy's history. In conclusion, I wish to emphasize that the impact many feel from the mysterious acceleration of 3I Atlas is an opportunity. It is a reminder that the universe does not always meet our expectations. As scientists and as a society, we must be prepared to live with uncertainty. We must celebrate our curiosity and at the same time be rigorous. We must be inspired by bold hypotheses without losing sight of the need for evidence. 3I Atlas will continue on its way, accelerating or slowing down depending on the forces we are learning to identify. Our task is to watch it carefully, learn everything we can, and above all, keep the flame of exploration alive. If this account has captivated you, if you feel that the quest for truth and the enigmas of the cosmos are an adventure worth experiencing, I invite you to share this story, to support it, and to subscribe to our channel so as not to miss the next narratives. Because the universe always has a surprise in reserve, and we will be here to tell you about it, no matter how fast the comet decides to accelerate in space.